Well, welcome back to another fantastic episode of Mr. Rodder's Neighborhood. Today, since we're waiting on our fashionably late parts again for our super stock small block, I decided to do a quick comparison against the timing covers big block Buick timing covers. They are definitely not all created equal. So I just wanted to go down the basic path of what's the differences and where the better ones can be found, the worst ones can be found, whatever is what can be found. But in reality, we all have the same problem when it comes to the big block Buick timing cover is there's very limited reproduction of these things. And if they are reproduced, you find that they're very chintzy compared to today's or the original product. Now, I have not, just to make things clear, I've never owned a TA performance timing cover, and it may be a completely different situation because that's their casting. So I have not had one, so I don't know how well their product is. I just know what I've seen in the past with the reproduction pieces from overseas and the factory. And so I personally will go out of my way to get a factory timing cover over a reproduction any day of the week. Okay, but to get things kicked off here, we'll start with this guy. All right, so this one, they all virtually look the same, but that's just at first glance because there is some discernible differences between them all. So this is a 67 to 69 400 or 430 timing cover. Like I said, at first glance, you think, okay, it's just a big block Buick timing cover. They're all virtually the same. Well, you would be dead wrong. Okay, so on the 400, 430, if you look at the initial timing settings on them, they call for 8 degrees before top dead center is the timing that they call for. So unfortunately, on the early timing cover, the 67 to 69, 400, and 430, the timing mark here, your little tab that's cast into the timing cover, only has 0, 4, and 8 degrees before top dead center mark. There's technically like I want to say maybe like a 10, but there is no number by it. It's not cast in there, and all it shows is 0, 4, and 8 degrees. Okay. Also, because of the early engines having the smaller oil passages, the oil passages are significantly different from the later ones. So if you look side-by-side comparison, this is your suction side, your inlet, and this one is considerably smaller than this here. Okay, so this would be a 70. It's probably 70 Grand Sport, like stage 1 and later, because the stage 1s were supposedly the first ones made with a 5/8 pickup. So I'm assuming the timing cover would have had to been modified to accept that 5/8 inch suction feed side. And this is a 71 and later timing cover are all virtually the same one. Okay, but if you notice, the opening here for the suction side is considerably larger. And that makes a huge difference when it comes to how much oil you're going to be able to get to that big block Buick. Remember, the mains on these things are 3 1/4 inches, which is bigger than the 350. It's bigger than the 300, the 215, the V6 Buick. It has more bearing surface, so it requires more oil at any given time, right? Because you have a larger surface, you have to have more oil volume to meet that requirement. Okay, so when Buick engineers sat down and designed this, I'm assuming was after the introduction of the small block. The small block was such a revolutionary design in 1961 when it came out that the big block took a lot of the characteristics of the small block. Okay, and it's not to say that they're the same. They're not. They're completely different. But it took a lot of the styling cues from that small block engine to make the big block. But what they did was they stuck with essentially the same oil passage sizes, which is like your 7/16. and you now got a huge amount of bearing surface. In comparison, if you think about it, okay, so the big block Buick had 3¼ inch mains. The nailhead Buick, which didn't have an oiling problem, it just had if there was a problem with the nailhead besides being just too damn sexy to be in a car, the heads did not flow all that well, right? Now, when they upgraded to the 400 to 455 family, some of these things were addressed, but the nailheads all came with a steel crank, and their mains were 2½ inch mains, okay? And because you have a 2½ inch main, which is ironically the same size as the 300 Buick main, right, and the V6 Buick main, you would think that the oil passage would, you would need a lot more oil. I don't know if they took that into consideration. I think they just kind of took what was already there with the small block and then just started building around that, because the small block, I'm in love with the small block. I love the small block, and the only reason that is because the Buick 215 was the first factory production engine to be used in IndyCar. It was such a revolutionary design and such a lightweight package with so much power that it became a go-to engine for Mickey Thompson in 1962 IndyCar program. That leaves a lot to be said. There's only a small handful of engines that have a claim like that. Besides the 215, you have a small block Chevrolet. It wasn't necessarily a factory cast block, but the small block Chevrolet was used. Then you had the V6 Stage 2 Buick, right? That happened in the 80s, in the early to mid 80s. The Stage 2 V6 was factory production engine. And that's what was great about IndyCar in the 80s, is you could virtually go down to your Buick dealer and order a complete Stage 2 engine over the counter and put it in your IndyCar and go run Indy. But leaving all that stuff aside, this smaller passage, in my opinion, was not enough to feed a big block Buick, especially like a 400 or 430, which was meant to rev, compared to the 455. The 455 was not designed for zinging it at high RPM. That was not the intent. When they went from the smaller mains on the nailhead to the larger mains on the 400 to 455 family, they did that by, the block was a lightweight casting, and the Buicks were one of the very first lightweight block castings used by General Motors, okay? And the nailhead was robust. It's a really, really heavy engine. If you pulled it out of a car today, you would be surprised at how heavy it is compared to everything else. Now, Buick shed the weight because it was mandated that they did, and what happened was the strength went out of the block. Okay, so to build strength within the engine, what they did is they created an engine with larger mains that put a lot of the strength of the engine, the core strength of the engine, in the crankshaft itself. So when they went to that larger main, it requires more oil. And if you look, that's why they updated the 70 stage 1 with the 5/8 inch passage. Every engine thereafter from 71 to 76 all had the 5/8 inch inlet side. The other major difference, here on the 71 and later, besides the inlet side, now the oil passages and everything essentially in the pump are the same. It's just the feed that's a little bit larger. And I have taken the older style ones out to a 5/8 inch, but wow, do they get thin right here. But okay, so all the passages inside the pump, they're the same. The casting for the 71 and later doesn't just have the 0, 4, and 8. It actually is 0, 4, 8, and 12 cast into the timing cover. That's how you can identify it's essentially a 70 and later. Now you'll have to look at the feed side or the suction side of the timing cover to determine if it's 70 GS stage 1 and later, or if it's a 70, because the 70 timing covers, if you have like a SF motor, what they call SF motor, which is out of like a full-size car, let's see, the Riviera's SR, so that's a 70 engine. So SF is like LeSabre, Wildcat, stuff like that. If you had a 70 car that was not a stage 1, it still had the 04, 8, and 12, but it had the smaller passages in it, like the early model timing cover. Okay, now if I show you this block over here, you can see the other big comparison that I wanted to show here. Okay, the timing cover holes don't necessarily line up with with the actual holes in the block, and that's because of where everything is located. Okay, so you can see this is a 430 block. This is an early one. This is a 67. So this is your oil suction side. Small little 7/16 passage, same as the feed, right? But if you notice on the gasket, it's got these oblong holes. And the oblong holes is because this is where your suction side from the pickup comes from. But the suction side on the pump in the timing cover is over here. It's on this side of the hole. Okay? The same thing happens up here at the top. This is your oil feed side, right? This feeds the block, and it essentially goes through here. It goes through this hole, and at an angle like this up to the number 1 cam bearing, right? And the main. All right. The feed coming out of the pump actually starts right here where this oblong hole is at. Okay, and now if you're doing oiling mods or block mods to a 455, you always hear the things like, okay, take out the flashing, which is, they're notorious for the flashing, right? So if you look in here, you can see the casting flash around all the lifters, the lifter bores. And there's quite a bit there. I mean, it's like a lot there, but as you can see, they took the thin wall casting very seriously, and it's open. It's one of the very few V8s that's open in the center. But when you're talking oiling mods and block mods, the next most important thing to do is this. Okay, so we come over here to this 455 block, and you can see, okay, you had those oblong holes. And since your holes line up in a different spot, not directly with the suction or the feed side, here, let me get you in frame, you oblong these out so that it's an easier turn, plus you have more volume inside that passage, right? Now I've already radiused these turns on this 455 block. These here are, I mean, it takes minutes to do this with a hand tool, with a rotary tool and a rotary file. So whenever you're doing any kind of block mods, this would be like one of the very first ones. And that, my personal opinion, besides the casting flash, take that out. Now if you look on the back of the timing cover here, because the holes are oval, they'll line up directly with those cut spots in the block. Okay, but that's just a quick rundown of 400, 430, and 455 timing covers. Hope you found it interesting and enlightening. If you have any questions, please leave a comment, and I'll try to get back to you as quickly as possible. Other than that, though, don't forget to show a kid how to run a lathe or a welder or a mill. Have a nice day.